Hello. The next part of any significance test is to mention the conditions that are necessary to perform the test. Now, we've kind of talked about some of these in the past, so this shouldn't be too new of a section for you. But the conditions for a significance test, we have to check that the data comes from a random sample, or an SRS, that we check normality and independence. So an SRS, this is pretty basic. When you're doing a significance test, you want to see that the data comes from an SRS. So when you check it, you just mention data comes from a random sample or data does not come from a random sample. Normality is a little bit more difficult to deal with. There's two situations for normality. The first situation is proportions. Now keep in mind proportions are things like 24%, 0.18, something like that. Those are proportions. And anytime we want to check normality with a proportion, there's two things we have to check. That n times p is greater than 10, and n times 1 minus p is greater than 10. And you should be used to that. We've been doing it for a few chapters now. Now, when we look at means, means are a little bit trickier. It's really easy. The sampling distribution is always going to be normal if we have 30 or more things that we're taking the mean of. So if n is greater than or equal to 30, central limit theorem tells us that it's going to be approximately normal. The gray area is what happens when n is less than 30. Well, if n is less than 30, we have to graph the data and assess it. Now, if data is relatively symmetric, if symmetric, then if we have, no matter if where it's at, even a low number n will probably get something that is really close to a normal distribution. Now, if not symmetric, if symmetric, it's enough for approximately normal. If not, we have a couple different options. One is if it's really not skewed, we say proceed with caution. So what that means is you can continue to do your significance test. This is just a warning to the people who are reading it that your probability might not be entirely accurate. Another thing, if not, is the data from a normal distribution. If data is from a normal, if population is normal, so if population is normal, then this sampling distribution is normal. Sampling distribution is normal. So that's another thing to check. And, and this pretty much covers it. There's some gray areas in here. If it's slightly symmetric, or if it's just slightly skewed, and you have an n of say 20, it's probably going to be pretty close to being normal as well. 30 is not a magic number. It just 30 is where we know that it's going to be really close to a normal distribution. Now, independence. Independence, it depends on the problem. If sampling without replacement, then we check that our population is at least 10 times as big as our sample. That's when sampling without replacement. However, not everything will fit into this category. Like if you're rolling a die 60 times, it doesn't make sense to say like there's more than 600 rolls in the world, or this person's going to roll it 600 times. So sometimes, if not sampling, then you can just assume independence. That's when it gets a little tricky. And if the data is not obviously independent, then we'll have to state that as well. And more of those will come up in the future. Now, what happens if those conditions are true or false? Now, let's just worry about if it's false. If SRS is false, if false, then we can't generalize. So if there's not an SRS, data doesn't come from that, we can't generalize to a bigger population. It's just, all we have is the data about the sample. If it's not independent, the probability will not be accurate, because we don't know, because the independence affects the standard deviation, and so that standard deviation will be off. Normality, if it's not normal as well, your probability will not be accurate, because we can't use a normal distribution and to find that probability. So if we did use our normal CDF, that wouldn't be accurate. All right, so now does the paramedic pass the conditions? So the answer would be yes. The data comes from an SRS. They have 400 examples. So SRS, they have 400 samples. So that's definitely more than 30. So central limit theorem tells us that that's going to be approximately normal. And we'll have to assume we're sampling without replacement. So assume there are more than 4,000 calls for the ambulance. If that's the case, then you pass all three conditions. Now the assembly line workers, do they pass the conditions? Well, the data did come from a random sample. So random sample we have. But the number of workers was just 18. So if we have 18 workers, that's not enough scores to assume normality. So we have to proceed with caution on that one, because we're not sure if what the distribution is there. Now independence, if there's 180 workers at the company, 10 times that number, then that would lead to checking that one. So that we'd have to assume that there's 180 workers or more in order for that to be accurate. All right, hopefully you can continue.